Hi everybody, my name is Vesatianen, and a few days ago I was told that Koenigsegg makes very light carbon fiber wheels for the Koenigsegg Jesko, and claimed weight is 5.9 kilos for the 9.5 times 20-inch wheel, and that's very light wheel for cars in that size especially. And I have tried now to 3D model the wheel to estimate how it has been probably manufactured, and I'm still wondering where does the weight come. So the weight of the wheel would be 5.9 kilos. I have modeled now that the barrel is 3.5 millimeter thick carbon fiber, and in the outer edge there's a huge chunk of carbon fiber there on the edge. Let's see that. So there is a lot of reinforcements for the curb impact test. On the outside, based on videos, there isn't much extra material there, but roughly the shapes are like that. And the poles actually are at the moment solid carbon fiber. So the whole part is now full carbon fiber, and the shapes of the poles are now pretty accurate. And the weight in my 3D program says 4.6 kilos only. So something very weird is going on here. If I get so low weight with so thick barrel, there has to be something not accurate. I'm guessing the barrel shouldn't be much thicker than 3.5 millimeters, because it's already super strong, as you can see from my FEM calculation. And the poles, only way to get it heavier is that you have some kind of inserts inside the pole. Is it aluminium, something else, and then you overlay the poles. But somebody who has these wheels should do a knocking test. Are they solid carbon fiber, or are they actually hollow poles? Because otherwise I don't understand where the weight comes to 5.9 kilos. But yep, let's look the simulation. So we go to simulation workbench. First see the actual bending test results. It flexes very minimal, 1.5 millimeter, but it's there. So it flexes almost nothing on the actual wheel. Let's see. There, 0.2 millimeter there, flexing. And that's nothing on the wheel. So let's look safety factor. Here I calculated it with 750 kilos max load, because that's what I'm designing now as my own field. The actual weight loading is probably 775, so a little bit more. But here it's very strong as expected. And if you look where the actual stress points are, you go down from here, you see the poles. Even if they are solid carbon fiber, they are bending and a little bit weak points, because there's only 5 of them and not so many. But if you put it like 1.5 or safety factor 1.3, then it's only minor stress points here in these corners, and those probably they have solved, because I'm lacking some radiuses in the corners, so it's not actually so bad. But 1.3 safety factor there on the bending test, that's okay. What kind of stresses it gives on the corners? 260 megapascal, and there in the spokes 200 or something is the highest stress points at the moment. The carbon fiber itself probably can handle much more, so even more, it's still an overkill to my instinct, at least, what carbon fiber wheels should handle. And then how much it flexes, that was nothing. Let's put it millimeter, 1.5 millimeter. But then if you could look the radial fatigue wear test. So you drive on the drum with the tire and full load here, and you see how it behaves. Now the safety factor is 0.7. Again, those corners are the problems. If you put it, was it 1.4 now? There, it disappears, this stress which is in the barrel. So 3.5 millimeter carbon fiber barrel should handle it quite nicely. Then you just need to look more carefully in the design phase on these poles ends. Do you have to put bigger radius or something like that there to solve that? And how much does it flex during this test? Again, it's always loses that I want to look millimeters. 1.9 millimeter, and that's very stiff. Normal aluminium wheels or forged aluminium barrels or roll formed aluminium wheels, it's like 4 millimeter range with this kind of loads in this side J3 to 8 test. And here I calculated 7.75 kilos, so it's the actual load for this wheel. When it's there on the spokes, it's probably nothing, but the worst case is in this case between the spokes. So what do you think? Where does the weight come? So I cannot be so much off on the design, because I used here you can see few pictures, actual wheel, direct photo, and then I scale it to match it and draw the spokes, and from the side then there is this side where I get how thick the spokes are from that picture. It's not 100% exact, but close enough. So what do you think? Carbon fiber wheels, why are they so heavy? And this is the lightest carbon fiber wheel there is. Usually carbon fiber wheels what I have seen are heavier than lightest magnesium forged wheels. So is the problem really that you're not able to design these spokes hollow? Because that's where you could get much less weight, because the barrel with 3 millimeter thickness weighs 2 kilos. If I put 4 millimeter barrel, 2 kilos divided by 3 millimeter times 4 millimeter, then it's like 2.6 kilos if it's 4 millimeter thick barrel. And if you put 6 millimeter thick barrel, then it's roughly only 4 kilos, and still you have enough weight for the hub area. In normal wheels, the barrel is 50% to 60% of the weight, and the rest is for the central part. And I think the rule of thumb should be close also here. You can make hollow spokes if you know how to do it, but why is it so then heavy? And even here you could see it was stress points was here, so maybe the design is not so optimal strength wise, but I'm sure they have spent a gazillion hours in the FEM simulations and design phase for designing the shape of this wheel, and I would like to think it's very well designed. So what's the problem? Can somebody who has been working with carbon fiber wheels give their estimates and opinions? What is wrong in my simulation and thinking? Thanks for watching.